Hey there, good afternoon there, YouTubers. It's about almost 6 o'clock tonight, and I've got my final version of my, well, it's not my final one, but one that's actually working, of my solid state relay. You've seen a previous video of the old one that I had. Well, I finally got the MOSFETs on this one. Got the extra thick wire and copper in here. Got my optocouplers. Everything else is pretty much the same, except for this time both sides are isolated, like I was saying once before. This is a 4-pin connector here. This red and black is red and black that goes to, see, the Colman air controller has basically 4 pins on it. It has positive, negative, where it tests the voltage of your batteries, and what it does, once the batteries get to a certain voltage, it trips, sets the relay to do your diversion mode. These 2 wires here are my relay wires. They are also going through both sets of these wires, the red and black and the white and blue, both go through bridge rectifiers. There's a bridge rectifier there, bridge rectifier there. This is a 12-volt regulator, 12-volt regulator. Alright, red and black, there's always going to be 12 volts on this side of the regulator, on this side of it. But it's not active until this is turned on, which then turns on the optocoupler, which then turns on your MOSFETs. Alright. There's I mean, everything basically looks exactly the same as the other one, except for the added few parts. This is my fan cable, which I also repaired, and new connector down there going into my fan. See if I can show you the MOSFETs. You might not be able to see it. My MOSFETs are hiding under there. There's 4 of them, 750 watts apiece. Alright. Now, before, the reason why I wanted to go with the solid state relay is before, when my batteries was drained down to a certain voltage, my current, you know, like right now we're at 24.6. I'm using a charger from a little power bike that I had to charge up the batteries, just so I can see this dump, or actually so I can test dump it a couple times to make sure this works. So I just installed it, and this is the test button up here, of course, for your Colman air. This is your activity light, and this tells you if it's dumping. We'll also have an LED on this system here to also let me know that, hey, I'm dumping, but if I ain't got a light on my solid state, then something's wrong with the solid. You know, it's a troubleshooting feature. And if they're both on, if I got to go for this, it means my solid state relay is on. Let's say if my green light's on, but yet I don't have a red, then I know I've got a fault in my solid state relay. So that's a troubleshooting feature, which that should never happen. If this burns up, transistors automatically shut down. Let's see here. 12 volts here. I'll let you guys see it, dump. I'll go ahead and push the test button up here. There you go. It's on. It's on. You know, you see my dump load, which is my power inverter's on. There's my test LED from my MOSFETs. Power's running through. And as you can also tell, you didn't hear the annoying clicking sound of a relay. 451 is what I'm putting in. Now there's some other tests I'm going to do, and like right now I'm putting at 27.8 amps. Before, every time this would dump, depending on where the battery's at, I don't even think it was really batteries, but the relays, you know, when they make a contact, they can bounce a little bit, causing really high resistance, because I've noticed there's some melt on my solid state relays. Or not my solid state. God, I can't talk tonight, guys. Sorry about that. On the relays that came with the charge controller. This is supposed to handle 40 amps. And you can see where there's been heat there. And what that is when these contacts bounce and they cause a little bit of a flutter, and they putting full power through, which is, you know, of course, burning up the relay for one, but also it's not putting out full current, ain't putting out full power. That's why I wanted a solid state. And as you can tell, it kicked off like it's supposed to. This will run for 15 minutes if my battery's at a certain voltage. If not, you know, of course, it kicks off. Once it drops down below 20 volts, it automatically turns off. So, I mean, everything's running pretty good. I wish I had some sun out right now so I can dump and so I can watch it dump. I mean, not bad. I mean, see, like before, if I had the other relays in there, it would just bounce and the current wouldn't go all the way up. So I think that might have been kicking the crap out of my batteries too, because it ain't taking a full current out, just a little bit at a time, you know, which is they weren't getting a full charge. And here in a second that'll kick back off. And once again, I'm still putting that full wattage back in at 447 watts. This is the 500 watt grid tie. So this is actually operating perfectly. It's not getting hot or anything. I got a fan in there. That's why I've always been testing it. Once those batteries get fully charged, I want to try to test that at full current, see exactly if it, you know, would kick down or dump out on me. But for what I can tell now, I'm doing remarkably well. Looks like everything's running pretty good. My next goal is to get some different batteries. I don't really care for these AGMs anymore. Another thing is, as you can tell here, I got a battery there, another set of batteries there, and a plug there that operates these. I'm going to be building a circuit for those also. And they'll have ground isolating transformers on there, where each one will be isolated from ground. That way there ain't no possible, you know, ground overlap, shorting out any circuits. So that'll be my next circuit I built. And now this is, I don't know if I've been wanting to consider this as my version 1 or version 2.0, since this is an actually working product and it's actually working good. But what I'm wanting to go to next is surface mount technology. That way, basically all this would be then is just input-output connectors, 4-pin header, fan connector, and LED, status LED. The rest would be just a flat circuit board. And the 12-volt regulators, we all know this doesn't handle a whole lot of current for this switching portion here, other than the solid or the optocoupler might handle enough current for the gates to switch on, which is I want to try to change that in the future as well. So I got what we call surface mount parts coming in. I got everything that you see on here that's on the top of here, I've got ordered as all surface mount. I've got 10 more of the MOSFETs ordered. Now there's a guy on the internet telling me about some other MOSFETs. They're a little smaller. They're the TO 220 case. This is a TO 263 case. They're a much bigger case. He said they have a lot of lower resistance per watt, so it's a lot less wattage per heat. When I added this up for these four, I have 45 watts at 40 amps. You know, that's heat output for 4 MOSFETs. So I could be losing 45 watts across that, which is, I'm going to test that out later. I'm going to take a jumper and hit across here and see if I'm still getting this. If I'm getting the same exact wattage reading as I do, you know, just shorten these out, which is basically turning it on, as I do as the relay kicks on, then I know I'm not really losing a lot of wattage. Alright guys, oh yeah, and this should be able to handle up to 3,000 watts. I've got 4 750 watt MOSFETs, so I'll probably be able to put another inverter on there. I probably won't put no more than 1,000, maybe 1,500 watts on there just for the heck of it. Just see how it works. Alright, I hope you guys enjoyed the video. If you got any comments, comment me, talk to me, let me see, you know, tell me what you know. I'll show you where these wires connect here real quick. There you go. They just come right up here to my Colman charge controller. See your red and blacks on your red positive negative input there, and blue and white. I can switch those, or I can, like the red and black, if I want to, I can put black on the other side and red on the other side, and the same way over here I can swap the blue and white, swap them around. That's why I got the bridge rectifiers down there. That way, if for some reason, let's say I'm tired and I was putting it back together and I accidentally swapped the 2 wires around, you know what I mean. We've all done it, and then we burned up whatever it is we hooked up. This here keeps that from happening. And I love it, you know, if this stuff was set up like it as well. That way, if you accidentally cross those 2 wires, you wouldn't burn up your, you know, Colman air. There's other safety features that could have been added to it, but you know, it's a cheap system, so you get what you get. Alright, I need to add fuses and everything else to this, but you know. Alright, well, that's about it, YouTubers. I mean, give me some comments, see what you say. I like to see what you guys got to say about it. Alright, talk to you guys later. Bye.